distance between the crest and the trough is the amplitude. The distance between a crest to another crest is the wavelength. The faster the sound, the smaller the wavelength is.
So our hypothesis was that as the temperature increases, so would the rate at which sound travels.
So the materials used. We had 4 basic materials, a tape measure, a 6-inch diameter metal pipe, and a metal knife, along with a metronome to measure the frequency.
So our procedure was we would go to Fairmont South Tower and take the metal pipe and the butter knife and stand roughly 100 feet away from South Tower in the parking lot and hit the handle of the butter knife on the pipe as Katie demonstrated. And that would resonate against the building as a sine wave would go and come back to create an echo. We would attempt to match our tempo of hitting the pipe with the echo that was heard. So we would hit at the same time we would echo. Then a partner would take the metronome and attempt to match the beats per minute of the metronome with our tempo. Then we would find the distance from us to Fairmont South Tower and then multiply it by 2 for our calculations.
So our experiment consisted of 10 tests, ranging from the degrees of 66 to 94, and there is a picture of Pedro in the act of actually doing our experiment.
These are data tables that we made. This is the first table. First column on the left is the temperature in Fahrenheit, and it's ordered from lowest to greatest. The middle is the beats per minute that corresponded with the temperature, and the final on the right is the speed. At 77, 83, 66, and 87, and 88, the speed falls under 1,000 and significantly drops for most of them. We believe these are outliers and were caused by variables that we can control, such as human error in matching the beats per minute to the correct pace and density of the air or humidity. Here's the chart that we made, and you can see that those 5 points really fell in comparison to the rest.
So when you go through and analyze, we would like to take out the outliers just so that we can get a more steady increase in the rate at which temperature increases. You can see that with our graph. To find the speed at which sound travels, you take 60 and you divide it by our frequency in beats per minute, and that finds the time it takes to get to the building and back. You take the distance, which is multiplied by 2, to find the total distance that sound traveled, and you divide that distance by the time you just found to find the speed of sound. What we found with our graph, without the outliers, was that 31.88% of the variance in temperature was actually affecting the speed of sound that we recorded, and the other 67.12% could be through human error, humidity, or other factors. That's our final test for it.
So in conclusion, without the outliers, our hypothesis was proven correct. However, the outliers could have come from, as stated earlier, humidity and human error, or even the medium, or the elasticity of the medium. Humidity affects the temperature in one big way. It causes the water vapor levels to increase, thus increasing the density of the air. This increase causes a slight increase in the speed of sound. With the elasticity of the medium, our 6-inch in diameter metal pipe did not resonate as well as anticipated with the metal knife, and so the echo received was not as efficient as it could have been. And then with human error, of course, matching up the echo with the metronome also could have led to statistical error.
Some real-world applications for our findings would be in military and flight together, kind of how far away an aircraft is and people on the ground due to the sound difference with the speed. In music, having an instrument
data, please? Yeah, we're right there, go back one more. So, you obviously decided that all of those that were under 1,000 were outliers.
Yes.
But to make the assumption from that everything went up, you know what I'm saying? So
Yeah.
that it's such a minute difference, I think that's a pretty large leap to make that assumption that you've proven that it does say, and I know you said you had some invalid data,
Yeah.
but you have to be very careful with that, so I think to make that assumption that yes, it did go up between that temperature.
Yes.
So, do you think that you would have had a more noticeable result if you'd been able to go down to much lower temperatures, like 30 or 40 degrees
Yeah,
Fahrenheit?
we would have liked to have done more temperatures, more tests in general, and also, we would like to control the humidity, because we started to realize that once we got these really weird numbers that started to dip down so low, we started to count, but it was too late at that point, so we couldn't go back. But if we were to do it again, we'd definitely do it with more trials.
Sure. Do you find then that humidity seems to have a bigger effect than this temperature?
We were not able to calculate that, but it might. That would be another test we'd have to run.
Okay, thank you.
So do you think a similar effect would happen if you could do it in different temperature rooms and where you had more variables that you could control? Like,
If we had the ability to change the temperature more, it would greatly affect our findings and have a wider range.
So would you say that like on the days where the speed of sound was lower, the humidity was also lower since sound propagates faster through?
Through what we remember, through our data, yes, the humidity was lower. On the days the temperature was lower,
I mean, no, not like on the days that the speed was lower, was the humidity lower?
also lower, yes.
Did you consider trying to fit your data to something that wasn't a straight line, something that might have a dip in it and see what kind of correlations you get?
We didn't think about that. We just assumed that they were outliers since the difference was so great. We expect a lot of it to be human error and just match up the beats per minute.
Can you find a specific number that would be an outlier, like the lowest number is an outlier, or you just assume that they were outliers?
We assumed anything about a 5-meter difference from 1,111 is about an outlier because that's at sea level, that is what average speed is.
What gave you the idea to use the procedure upon which you use?
Our science mentor, Mr. David Lamb, actually gave us the idea to use the procedure and here was that was it.
And what gave